All right. So, formally beginning from the start, we are dealing here with a lot of different kinds of data. Data has many flavors. When I have different flavors of data, when you talk about different flavors of data, I told you the classification of data into many types, that basis of classification is the event. Correct? The event which produces the data is what changes the data. The real event which produces the data is what changes it. Okay? One second. So, the different kinds of data that you are now looking at here, you see, are numerical, discrete, continuous, and you can see it is discrete because the event itself is going to allow you to only make discrete computation, like how many purchases did a customer make in a year is discrete, how many times somebody can flip a coin, it is discrete, right? So these kind of discrete events will be there. Next, continuous, you see how much time did a user take to check out. It can be 15 seconds on this, that is luck. 15 seconds on the clock it can be, but usually it is 15.6 or 50.8. That decimal number is allowed. That is continuous data. Next comes your categorical data. Okay, category is what you are going to represent: your gender, yes, no, race, state, residence, product category, political. This one you have to understand. You may also, Manjunath, you may also want to go and check the video that I have shared.
Yeah,
Then
got it. I am able to recall now. Categorization. Yes, yes,
right,
yes,
and then
yes.
ordinal data, where you convert the numerical to ordinal by giving it mathematical meaning. Okay, categorical data also you can assign some numbers, but they don't have implicit mathematical meaning to it. Okay, so implicit mathematical meaning, this you can assign numbers to categories in order to represent them more compactly, but numbers don't have mathematical meaning. This is what you have to carefully always understand. Why? Because like this. Say, suppose you are asking, Vikash, would you like to explain what it means? You can assign numbers to categories in order to represent them more compactly, but the numbers don't have mathematical meaning.
Yes, sir. So if say we consider the states of India as an example, so there are totally 26 states that we have. Uh, so each state we can assign one number to that. So that is what we mean by categorical, in which we can assign number to those categories, but there is no meaning. Like one is not greater than two or two is not greater than three. Each of them is a different entity in itself. And this is something which we call as nominal data, I believe.
Yes, nomination only. Even if you assign number and just for the brevity, just for alphabetical change, ordering, you may want to reorder it,
Uh,
but that reordering will change nothing about the information. Okay, it is just for our convenience that we are reordering the data. You're getting it, Manjunath?
Yeah, got it. So we are categorizing the laptop. It's nothing like this laptop is great in the Lenovo. So Lenovo have many categories. So it is not like that this particular Lenovo is great. Everything is just categorized and kept it as this
Hmm.
is i3 version, i5 version, like that.
Hmm.
That's what my understanding.
Right, right, right. That's the right one.
It's not audible, Vijay. I'm not
One
able
second.
to hear.
I'm there. You're able to hear
Okay.
me? Huh? Okay.
Yeah, 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 we are able to hear you. I'm able to.
Now, the ordinal one is a mixture of numerical and categorical data. The ordinal one is a mixture of numerical and categorical where you assigning a number actually means something. For example, here you see you can ask these kind of questions like on a rate of 1 to 5, rate the movie Salar. So everybody is giving different user 1, user 2, user 3, user 4. They have option to choose from you know good, bad, worse. Correct? Good, bad, worse. You can now assign a number to this. You can say good means okay, let's give good means 4. Bad means let's give good, bad 2. Worse means let's give this. Excellent means let's give it 5. Okay means let's give it 3. Now this is actually an actual number assigned to these values which has mathematical meaning because there is an order to it. So most of the time, this is the problem. The most of the time, your categories will have to be assigned to ordinal. Most of the times, you'll have to bring in the categories to ordinal. Okay, this is what we'll have to bring in. So basically, this is the takeaway. You have to write this down. Okay, most of the data scientists' problem, if you, I'm pretty sure that you are having a small notebook next to you where you make notes. So if you want, you can make this star, double star, because it's important. Most of the challenges of a data scientist is whether the data scientist is able to convert the categories to ordinality. Okay, means what? How can you explain what is the meaning of this?
Here meaning is got changed completely. So it is number one means not a, it's a number one beautiful or excellent. So the number one is giving for the worst. So the value, the sentiment, or what we call the exact picture, sorry, exact statement or exact result is something is different. So number one is not nothing like that. It's a number one movie. So something like that.
Mm, a little, I was not convinced with that answer. Let me,
Okay.
Vikas, you would like to try categorical to ordinal.
Yeah, sure, sir. So categorical data as such, they don't have any differentiation. I mean, we saw that there are different categories which don't have any precedence of one over the another. But when we have it as an ordinal data, we are we are creating an importance amongst that. Like say we are saying that this is superior to this. So there is a very clear distinction between each of the categories, and For this, we are using numbers. So that is where the combination of categories and numbers comes into.
Correct. Category is only a nomination. These nominations, you remember this nomination cannot bring to the, cannot get you to this. This is the picture you should remember, Manjunath. This cannot happen. Categorical data, which is just a nomination, cannot be brought down to reference system. This is making sense? For example, see, students in classroom. Students in classroom ask their religion. So you will have Hindu, Christian, Muslim, Sikh, Parsi, many more. Okay, this is just nomination. Calling them HINDU. HINDU is a word, no? It's just a word nominated to represent that. A word nominated, correct? We cannot bring this here to the reference system because we bringing to the reference system means what? Bringing it to the reference system means what? Means it means it has an order. The moment you bring it to the reference system, it is implied that there is an order. This order is the word. Okay, but here this has no order. We cannot say Hindu, Christian, Muslim unless you attribute another field to it. What that field could be? Now you can ask population in the world. Then you will attach, okay, Hindus are so many numbers. Then you say Christian are so many numbers. You say Muslim are so many numbers. Then you bring it to the reference system saying on the basis of population metric, this is the measurement. So you will find so much here, so much here, so much here, so much here. Now you can actually name it like this. Okay, you can say Hindu, you can say Christian, you can say Muslim, you can say Parsi, and all that you can say. Measurable. Only the category or the nomination itself is not measurable. This is what I mean when I say converting the nominal data to ordinality. Nominality and ordinality. Right? So I hope a little. Now let's talk about this. How much gas is in your tank? What kind of data is it? Can you tell me in terms of discrete, continuous? Tell me in terms of that.
So it is numerical and continuous.
Okay. Manjunath, please tell me this. A rating of your overall health where choices are 1, 2, 3, 4, corresponding to poor, moderate, good, and excellent.
This is not gives the reference systems.
Tell me what data it is then.
It is sorry, non-relative data.
No, you are creating a new category now. There are only, how many categories are there of data? Numerical, categorical, ordinal. Only three are there. Numerical data, categorical data, that is nominal, and ordinal data. We just explained this. Numerical, categorical, ordinal. You have to
It's a
make this.
categorical data.
This is not categorical. Here, a rating of your overall health where choices are 1, 2, 3, and 4 corresponding to poor, moderate, good, and excellent. Now, when you see this poor, moderate, good, and excellent, this is category. But a rating of overall health where choices 1, 2, 3, or 4 corresponds to poor. So 1 corresponds to poor, 2 corresponds to moderate, 3 corresponds to good, 4 corresponds to excellent. That which means that poor, moderate, good, and excellent can be reordered, correct?
Yes,
Then it is what? What data it is? If it can be ordered, then what data it is? If it can be ordered, then what data it is?
ordinal.
Ordinal. Okay. The races of your classmates. Tell me this, Manjunath. Races of your classmates. What kind of data it is?
Races means in the sense
Religion.
religions. Okay. So religion is not. It's a categorical data.
Categorical.
Yeah, categorical.
Categorical data. It is not ordinal, it is not numerical. Ages in years. What data is it?
Age of years is a numerical.
Money spent in a store.
It's a numerical.
Numerical what? Discrete or continuous?
Continuous.
Okay. Now you got.
ಸರ್ ಇದೊಂಚೂರು ಬರ್ಕೊಂಬರ್ತೀನಿ ಒಂದು ನಿಮಿಷ.
What? This quiz?
ಹಾ
I'll send you the picture.
ಓಕೆ.
The video itself will be shared with you, so you can.
ಓಕೆ.
So now this brings us to our first, you know, uh, layout where we start computing stuff. So your data's general classification you have understood so far. Now let us understand how you get data for analysis. When you get the data for analysis, somebody collects the data. Someone collects the data, correct? Someone collects the data. Agree with me?
Yeah, someone has to collect the data. Yes.
Somebody. Why? Why are they collecting the data? Why?
For analysis.
Okay. For analysis of what?
End result.
No. End result. Analysis of end result of what?
Of the data.
Okay. So the data is actually representing what? For analysis of, this is the
For an event, sir. Yeah.
Event.
Yeah. Okay.
Event which produced the data. Correct?
Yes, yes. Event will produce the data. Yes.
So if now let me just collect the data. I will just want to make sure that some color things are used so that it makes an impression for you guys. Somebody is interested in the data means they have realized that now for why do they want? Now the question is why do you want? Why do they want to analyze the event? This is what I'm asking. Why do they want to analyze the event? Answer this question.
To know the impact. And for decision making.
Anything you want to add,
And if it's
Vikas?
yes, sir. So if it's a favorable one, we need to understand how to how to recreate it. And if it's an unfavorable one, then we have to stop it. So these two things we can
Control the event,
correct.
Yes.
mitigate the effect of the event. Hmm?
Yes. Yes.
So to be able to do this, first you should understand that when somebody collects the data, they, when someone, they clearly know the variables or parameters of the event which is being observed. Correct? When someone collects the data, comma, they clearly know, they they clearly they clearly know the variables or parameters of the event being observed. Correct or not? They are supposed to know, right?
Yeah.
Based on this clarity, based on this clarity, the variables are. So out of these variables here comes two types of variable. One is features, one is your target. Okay, features are those variables which are changing and is affecting the target. Okay, and target is the variable which actually is being analyzed. Okay, so end result is, the end drama is that an algebra of the relationship between features and target variable, this is the end goal. Okay, the algebra of relationship between feature and target variable is the end goal. You agree with me? Is it making sense?
Yes, yes, sir, yes, sir.
Yes,
Yeah, it's making very much. I can even attach to the real-time world also for this example.
Tell me, go ahead.
Yeah, 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 we have RBI is the
You have certain clarity.
so what will be the so why every quarter they will come up with the inflation data ಹಣದುಬ್ಬರ ಏನಾಗಿದೆ ನಮ್ಮ ದೇಶದಲ್ಲಿ ಅಂತ that means okay, so if the common people has to leave that total inflation data has to within be within 7 or within 6, so that the common people can lead the life. Otherwise, he cannot lead the life common people. So that time, the through the data, RBI will came to know. So we need to bring if the inflation data is more than 7, more than 8, more than 10. If then that has to be bring it down, that inflation data has to be bring it down. This inflation data is calculated by in two ways. So one is how much productivity is happened in the industry, how much productivity happened in the this one agriculture industry, agriculture field, and what is the sale, how the people are purchasing. So these two, productivity and selling. So these two things will decide the inflation data. So that time the RBI will come up with the policies to reduce the inflation data in the futures. So target is they have to reduce the inflation data to make the common people life easily, so they can purchase the things easily. So that's what. So during the COVID also we know that. So because of the COVID, the agriculture field is not means the productivity is decreased. So the inflation data is become increased, means for the rice, for the food things, everything is become increased. So because of the RBI policies and central government policies, they bring that event is that event happened, the COVID event is happened, then they targeted and they bring down after 1.5 year. to the normal inflation data. That's it.
Correct. That's the target, and whatever features you collect to observe that relationship, that's the feature data like agricultural produce, selling demand, and all these prices of MRPs and all that areas and different
Yeah,
places. In that only your ordinal, nominal, and quantitative measures come. Okay?
yeah, that's what demand and supply. So in simple thing is
Right.
demand and supply.
Right. I hope, yeah, I can understand that you are connecting the dots, but you will now see the mathematical way of connecting it. You should be domain agnostic. You should not get into one particular domain because this data tomorrow might come from health or might from finance or from retail
Yeah,
or from medical.
COVID also. So
Yeah,
COVID
anything. Yeah.
now it is started. So we can take real time example also. WHO is also warned to the India. So you have to be very clean with your data while giving the data to the world.
Hmm. Why? They were not clean earlier?
That's what they suspect. So now the third wave is they clearly told India has to take more. That is one breaking news from big on the COVID news part.
Okay. India has to take
So
what?
just
More samples?
yeah, they want to take the more samples because of this. I'm not able to recall this COVID whatever muted no, some muted name is given that is already spreaded into the community.
Hmm.
So the preparation is started. So increasing the testing, increasing
Okay,
the
okay.
ICU beds, increasing the mask, yeah, awareness, increasing the awareness
Right, right.
to bring the inflation, COVID
Hmm.
inflation.
Right. Okay. Fine. Yeah. The coming back to our topic, we will now see how the data looks when it is given to you. This is how the data looks. Okay. Before I even start with mean, median, and mode, I want you to understand something very, very clear. Where mean, where median, where all these kind of statistical stuff are applied, why they are applied. Uh, I want you to understand. That's why I'm putting this together. You see, this is the data that I have just ingested in the data tab, statistics tab, the software. And you see this nominal, are you able to see this here? Automatically it is,
Yeah, I
yeah,
can.
nominal data automatically auto detected it is. Then this is metric data. Metric means your numerical data. Okay. This metric data or numerical continuous, numerical discrete both come under metric. So your metric salary is metric, age is metric, place is nominal, weight is metric, company is nominal, see, nominal, then academic degree is ordinal. Hmm? So this differentiation you have to understand. Before we start understanding everything, the first thing what we have to understand is each variables, the way in which each variable is changing. This each parameter, right? Each variable that you have, each variable how it is changing. This is the first step. Agreed or not? Before I try to get the whole picture, don't you think first we should understand the distribution itself? So this particular thing, this whole thing here is called the distribution of the salary. It is called, or you can say salary distribution. Hmm? Correct? You can say
Yes.
salary distribution.
Interesting, interesting. Yes.
So this is the distribution of age. How? Because salary in this particular data, in this event, this is a local event, not some physics property where everything is same. In this event, in this collection of data, Somebody with age 33, they are earning 1,500. Somebody with age 55, they're earning 3,000. Somebody with age 36, they're earning so much. This is a different kind of event. The same event, I can keep this, but I can change the event of the collection itself. If I make this entire, if I take this person who collected this data, if I direct him to Silicon Valley, I'll say just go to Silicon Valley, go 10 kilometers around that place and do the same experiment. There you will see salaries going in the range $10,000. Same age will not change. But here one more zeros will come. That's the salary distribution of around 10 kilometers of Silicon Valley. See the where the data, when the data was collected, everything matters to that distribution. So this is a distribution, this is a distribution, this is also a distribution. However, you can't do anything with this because it is nominal. There is no computation possible. Maximum you can find out the mode. Okay, they cannot find the mean value of this. You can find the mode of this because you can say mode is 1, 2, 3, 1, 2, 3, 4, 5, 6. 6 is the Ford is the mode. Means mostly Ford is repeating, no? So for the kind of categorical data which it is, your Ford is the one which is repeating. But here you can find average, mean and median of the distribution. Okay, so we'll come to that mean and median of the distribution now. There are for the distribution that you have, depending on whether it is metric or nominal or ordinal, you can measure the central tendencies. Measure the central tendencies. Okay, this name was given later. Okay, first they want to calculate the mean value of it. When you have a lot of numbers that are given, if you see instinctively, the first thing that you can calculate is the mean itself. The most simplest thing that you can calculate of a distribution, of a distribution. The first stuff that you can calculate about the distribution is the mean value. What is that? You are going to sum everything and divide by number of data points. This is the mean. You can do this for all. You can find the average. So this average value also represented as mu, mean, okay? This tells something about the central value, correct? This tells something about the central value of the distribution. Am I not? Am I not seeing that? Hello?
Yeah, sorry, Vijay.
Yes, sir.
You're able to sense that, right? That
Correct.
Yeah, yeah.
something about the center. So this is uh, important picture that I would like you guys to. And the way I want you guys to understand is now that the event has been given to you, now that the numbers has been collected for you as an analyst or a data scientist, calculating the mean value gives you one number. One number which gives us a sense of central tendency. That one number is important. Okay, it gives us the sense of that central tendency. This is why we calculate many computations in statistics, because it is one number which gives us a sense of sometimes central tendency, sometimes a drift, sometimes many other things. But we need one number which gives us a sense, a number which gives us a sense. This is the gist. Can you find a number which gives us a sense? What sense? Here in this case, the sense of its central tendency. Centrally, how it is behaving. Tendency means behavior. Okay, tendency means behavior. Centrally, how it is behaving. Can a number give us the sense? Can one number give us the sense how this distribution is behaving with respect to its center? That number is mean. Another number which gives you the same feeling is also called as median. Another number. But there is a difference between mean and median. We'll find that out. Okay. So before I I'll close this. Check if you have got the picture properly. Yeah, I've got it. I'm going to close this. Now, making sense, Manjunath and Vikas, two quantities are there. All quantities computed so that you get the sense of the distribution. Finally, what you are trying to make sense of? The distribution. How centrally the distribution is changing, or how centrally the distribution is positioned. For that, you need the mean and the median. Mean value you already know. Median value is you have to find out why it is done. So let's go to the slides and we'll get more sense. See the mean value of 0, 2, 3, 2, 1, 0, 0, 2, 0. The mean value is you take all, add all, divided by number of terms. So you get 1.11. Great. But when it comes to the median, you sort it. You sort it and you take the middle value. That's the median. No addition, no average here. Okay. You sort it, you take the middle value. Okay. Now I will give you a, one second. Now I'm going to give you a distribution. Take this down and tell me the median, mean and median of this. Hmm? Give me the mean and median. Can you calculate and give me quickly, both of you?
So ಸ್ವಲ್ಪ ಫಾರ್ಮುಲಾ ಬರೆಯಕಾಗತ್ತಾ?
ಫಾರ್ಮುಲಾ ಏನಿಲ್ಲ ಅಲ್ವಲ್ರಿ ಅದರಲ್ಲಿ.
2 plus 7 plus 8 plus 6 7 plus 90 divided by 1 2 3 4 6
Yeah,
divided by 6.
yeah, that's it. That is your average.
Okay.
That is the mean.
So mean
Mean is
average.
How the mean is average? How
Okay.
mean means average? Vikas, you have a number for me?
yes, sir. It is 20. The mean is 20,
Oh, okay. Median is?
and the median is 7. 7.
Okay, great. So you got the mean value, you got the median value, correct, Manjunath? For the same.
Sir, understood. What is mean? What is median?
Wait, now when to use it? If I suppose there is an institute, suppose there is an institute, 30 short, and 30 short says after placement we have an average of uh, 15 LPA. Hmm? After the course, 15 LPA average package our students are getting after data science and ML and all that. And that gives you a good sense of positive feeling, correct? Oh, 15 LPA average after finishing the course, which is very good. When you want to do career transition, freshers come in, and for those people, it is very nice. It looks very nice. Suppose this distribution came into the picture because of something like this. I'm making a wild guess. What is the average of this? 30, 34, 40, 47 divided by 1, 2, 3, 4, 5. Nines, around 12. So if I had said 12 LPA, okay, see, I'm telling that my average students is 12 LPA. But turns out that one of you who are already, like, let's say Manjunath, he's already at a certain package now. Okay, he's already at a certain package, and after finishing this course, there's highly likely that he will be touching somewhere 32, 35 LPA. But in the same distribution, if I add all these other freshers who got a placement, some people may have got for business analytics fresher, some people 1 year experience business analytics, and suddenly 16 year, 17-year experience person with 35 LPA. Add this person also to my distribution, your average becomes around 12. Correct? You're seeing this?
Mm.
But what if now, Manjuna, tell me what is the median of this?
Uh, four ಬರ್ಕೊಂಡ್ಬಿಡ್ತೀನಿ ಫಸ್ಟ್
ಅಲ್ಲ ಹಿಂಗೆ ಮಾಡ್ಬಿಡಿ, ಅದರಲ್ಲೇ ಏನಕ್ಕೆ ಬರ್ಕೊಳ್ತೀರಿ, ಇಲ್ಲೇ ಮನ್ಸಲ್ಲಿ ಮಾಡಿ. 7645.
ಮಿಡ್ಲಲ್ಲೇ ಮಾಡ್ಬಿಡೋದು
ಹಾ,
ಒಂದು
ವಾಟ್ ಇಟ್ ವಿಲ್ ಬಿ 45
35 ಸರ್ 3,5 ಅದು
35 4 6
4 6 4
4 5
10
6. See, 4 5 6 7 35. What is the median of this?
5 6
No, median.
median is 6.
This Yes, you sort the value, then take the middle value. So the average was 12, median was 6. So next time you go to an institute or take any quantity where people are telling the average, don't you think you should ask the median to them instead of the average?
Hello.
Hello,
Yes, sir. Yeah.
don't you think we should ask the median instead of asking the average?
I think I'm not. It's already not audible for me.
Vikas, you're able to
Its
hear
voice
me
is breaking.
Yes, sir, I can hear, but there are some disruptions here and there.
from a long time. It's like this.
No, sir, just last 5-10 minutes, I'm able to feel this. Yeah.
Better, a little better now.
Yeah, it's better now.
Okay, now my question is, should you ask for the average LPA of students getting placed from an institute, or should you ask the median LPA or a median package that a student is getting? What should you ask? Average will give you 12 in my case. Median gave you 6. What would you ask, Vikash?
The median, of course.
Only median, or would you go extend a bit more and say, tell me both?
Uh, so actually, this median and mean on most of the situations they will be similar, except for those cases where there is some extraordinarily outlying information, like this 35 LPA case that we considered.
Yes, yes,
So to understand what is the extent, maximum possible extent, we can ask the mean also in such cases.
yes. In fact, you should always be asking both the mean and the median. Okay, and then see the percent difference between them. When you see the difference between the mean and median, you will come to know something about the distribution. Otherwise, just median alone will not give you the information about the distribution. Just the average alone will not give you the information of the distribution. The values hidden in both the mean and the median, their difference is going to talk much about the distribution. Okay, that is what I wanted to draw your attention to. Hmm? Manjunath, you're able to follow this? Simple computation, but calculating your mean, we say mean is affected by the outlier. Manjunath, not able to hear you.
Yeah, I'm able to follow you. Mean is affected by the, what is
Outlier.
it?
Outlier.
Outlier means,
Something which lies outside, like
uh,
your 4, 5, 6, 7, suddenly
okay,
35, right?
okay.
This is lying outside, right? This one.
Yes, yes, 35 are lying outside.
Now, how much is outside is another problem, because how do you know 35 is outside? What if you have 4, 5, 6, 17, 23, 39? Now, which one is outside here? If you start thinking, you will say, okay, we can see these are all, even if this had become, let's say, 11.
But we need to
Now,
sort, right?
yeah, you sort it, fine, this is already sorted.
Okay.
You see here, you will feel that these are all same, correct? These are around each other, and this one and these two are lying outside.
So, sir, why we not consider 23? It's not lying outside
I'm,
because it is
I'm
not equally distributed, right?
Now you see this difference between this and this 6. Difference between this and is 6.
Okay.
Difference between this and this is 16. Again, difference between this
Okay.
and this is again probably 6. So you will probably even add this inside that. I don't know. We don't know. Okay. We will have to figure out a system which will automatically detect the outlier. So I'm saying
Uh-huh.
just because you are looking at some big number in a particular example, not only the big number is not the only outlier all the time. This small number here in this distribution is also the outlier. This is also not belonging to this smooth, this one, and this is also not belonging to this smooth. Okay, so you can just check. Suppose I ask 1,000 people. Okay, I ask 1,000 people how many heads they have. Heads, they're on the head. How many heads they have? All 1,000 people, I'll get one, 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 correct?
Yes.
So what will be the average of this? Mean value?
1000 only.
1. 1.
One.
How it will be 1,000?
Uh,
1 plus 1 plus 1
the
plus 1 will become
average.
1,000. 1,000 by 1,000 is 1.
Okay.
Hmm? Hmm. Salpa, you should go back and
Fine.
do some mathematics calculation. Arithmetic mean, median, mode, permutation, combination. You have to take this one, Manjunath. Okay, from
Uh,
27th onwards, when I will take a small short break where you make sure that you go and practice all this arithmetic. Otherwise, see, if the arithmetic is not happening in your mind, you will not get feel for examples. Hmm?
okay.
A little bit of that is important. Now, median is
That would also be ones.
1.
1.
Both mean and median are same. Mean and median, if they are same, it means the distribution is so uniformly distributed. In fact, it is a perfectly uniform distribution. Hmm? So you're getting to uh, this feeling or this final decision about the nature of the distribution using only mean and median. You can get it. It's a very simple computation, but with just the
Yes.
understanding of median and mean, you can get to know whether there is an outlier. Because in this particular case 4 5 6 7 35, mean value was 12, median was 6. So percent difference between mean and median 2 times, right? So 100% difference, correct? Your mean was 2 times the
200 times.
median, correct?
Yes.
So 100% increase from the median to mean, right? So this doubleness will tell you that, boss, mean was so much, median was so much, suddenly mean became this much, means what? Somewhere there is an outlying element. So we need to detect it. And if now tell me, 1,000 people you have asked, okay? 1,000 people you have asked how many heads they have. Don't you think you can bet your money on the 1,001th person? You don't have to ask him. You can bet your money saying it will be one, correct?
Yes,
Would you not bet 1,000 or 10,000 rupees on it?
not required.
Right. You will not worry about it. You will bet. You will bet the 10,000 rupees on it without risking it. Why? Because you have seen that the mean equal to median and there is all complete uniformity in the distribution. Why uniformity is important? So that you are able to, what are we checking for? Why we are checking for outlier? Why are we checking for if mean and median is related or almost same? Why? Because it gives us the feeling of the distribution itself. Why is it important to understand the feeling of distribution? So that you can predict. It gives you predictability. It gives you the power to predict, or it will give you a feeling of how risky it is to just assume something, or should you assume or not. If something is like this, 2, 7, 16, 9, 5, 12, 41, 4. Now predict the next number. Will you bet a 10,000 rupees on it, on guessing this number? This will be purely gambling, correct?
Yes, yes, it's a gambling.
So this the whole idea of your understanding, a statistical understanding, and finding out mean, median, mode is to figure out whether you are taking too much risk in guessing this new number. Is it guessable or not? This new number. That is what the whole thing is about. Okay. So what is the summary? What is the summary of this? I just
Summaries like this mean and media. So we need to median. We need to find it out. So that's what we understand mean and media.
median,
So
mean and median.
median. Okay. Median.
Mean, median, and mode. Three M's. Okay. M, M, M. These are measures of central tendencies. See, measuring the central tendency, behavior around the center. To measure the behavior, measure the behavior of the distribution around the center. You need this mean, median, and mode. Hmm? Anything you want to add to this, Vikas? Any other statement that I forgot to write here?
No, sir, I think it is all fine.
Measure the behavior of distribution around the center. Measure the behavior of the distribution around the center. And calculate its predictability. What? Distribution's predictability. So basically the idea is that only. Okay. Basically, the end result is that you have all this. Okay. Can you guess the new one? This is the money. You know, for 11 people, you know, or 12 people, you know. Can you guess the 13th person's salary? And can you, based on the age here, or can you guess the 13th person's age? Or if you build an algebra between both, I will give you the 13th person's age, 31. Can you guess the salary for it, for this person? These are the questions that we are trying to find answers for. So first thing is first, you first appreciate the question, appreciate the importance of the question. Once you appreciate the importance of the question, that why this question is important, why finding the answer to this question is important, when you appreciate that, then you will have motivation to go into the system. See, it's always like, oh, Viktor E. Frankl has said, a very great writer, a Holocaust survivor, he said, if you are clear about your whys, hows will not matter. How to calculate, you know, nobody has to motivate you to go and find how to do it, because your motivation comes from why to do it. Okay, that's why I'm saying appreciate the importance of the question, find the importance of the question, and then hows will come not automatically. You will find, either you will find out your own reason for it, or you will go and search whoever has found it out, as long as you are clear about the whys. So that's why we have to be clear about the whys of your central tendency. And think about it. When a distribution is given to you, this bare, naked, minimum distribution, what can you do with it? Nothing. You can only first find the mean value. Then you can find the median value. And if it is not a metric, and if it is something like a nominal, you can't even find the mean and median. At the most, you can find the mode. Okay, so let's go and check out what that mode is. And you've already seen what mode is. See, this is the mode. Mode is the one which has repeated. What has repeated here? 1, 2, 3, 4. In this distribution, 0 has repeated. So mode is 0. And of course, here in numbers also you can do, not a problem. With numbers also you can find the mode. But I'm saying there's no meaning for the number of having the mode. In terms of your nominal data which is there, then there is a mode. The meaning of mode comes out of picture. Otherwise, see this continuously changing numbers, the mode doesn't make sense. Because it is continuously changing, what is the meaning of mode? Okay, this comes into the picture only when there is a nomination. So sometimes you have nominated, suppose just for simplicity, you have said everywhere there is female, let's write 2. Everywhere there is male, let's write 1. Okay, so you have 2, you have 1, 2, 2, 1, 1, 2, 1, 2, 1, 1, 2, 3, 4, 5, 6. Now 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Oh, it's 12, 12, equal. So when it comes to this equal, what will be the mode? There the mode will be 1. The one which is smaller number, no? That will be the mode. But of course, this doesn't make sense. When it comes to this thing, it doesn't make sense. Anyways, we'll figure out, we'll understand whether uh, a smaller number for a nominal data, when you attach a nominal number to it, some rules and regulations will change. Hmm? So for that, to get that understanding, you will have to a little, it'll take some time before you get the feel for it. So basically, what did we study today? We studied mean, median, mode. Okay. Now I want you guys to take a break. Hmm?